Hey guys, we're going to do homework 2-2 part 2, and you should have the answers to the odds. So I'm just going to show you the answers to the multiple choice because I think those are how a lot of these questions come up on the test. So let's do it. The multiple choice are 85 to 90. So 85 says, to measure the center marked on the density curve, which of the following is correct? So if we look at this density curve, then this is definitely skewed right. So since this is skewed right, it's called skewed right. That must mean that the median is here and the mean is pulled to the right. So in skewed right data, the mean is greater than the median. It's to the right on a number line. This direction is right, correct? So my answer would be the red line is the median and the mean is the yellow line. So it looks like our answer is B. Okay, let's take a look at the next one. It says, referring to question 86 to 88, the following setting applies. The weights of the lab cockroaches can be modeled with a normal distribution, having a mean of 80 and a standard deviation of 2. The following figure is normal for this distribution of weights. Okay, so this is kind of our flip chart will be helpful for us here. All right, so our mean is 80 and our standard deviation is 2. All right, so then subtract 2 and I get subtract 2, subtract 2. Add 2, add 2, add 2. Right? So that's approximately what we got going on here. See what I'm saying? Now it says point C on the normal curve corresponds to what number? So C is 1 standard deviation below. So 1 standard deviation below, this location is mu minus 1 standard deviation. So if the mu is 80, 1 standard deviation is 2. We get 78. Let's see if we can find our answer. 78. Beautiful. Now let's look at part 87. It says, about what percent of cockroaches have a weight of between 76, so looking at my sketch here, 76 and 84. So 76 to 84. So that's 2 to the left and 2 to the right. So that's 4 flaps. So kind of using our flap chart, I got to add the 4 center flaps. It's 13 and a half, right? 34, 34, and 13 and a half. We could have also opened the flaps and noticed like, oh, this is 68 and this is my 95% rule. So those should add up to 95. That's another way to do it. So answer is B, 95. All right, 88. About what proportion of cockroaches will have a weight greater than 83? So now we got problems. We got to use a different method because it doesn't fall right on a flap, right? So we got to use the other method here. So I'm going to make my graph 80 and my value is 83. Now I have to find out if I do my standardized graph 0, what is the z-score here? How far above the mean is this relative to the standard deviation? Okay. So we should be able to find the z-score here. Z-score is whatever my value is, right? My actual value minus my mean over the standard deviation. So my value here is 83. take away my mean, and we said our standard deviation is 2. So I get 3 over 2, or 1.5. Okay, so I have my picture, unstandardized, picture, standardized, and I have my z-score. Now I just have to find out the proportion that would weigh greater than 83. So I got to shade this. I need to know the area under the curve to the right. So it would be the same in either graph. It's the same shape, but my table A would tell me the area to the left. Okay, so here, the area to the left, well, the z-score will tell me, z-score table will tell me the area to the left of 1.5. So let's take a look. Let me get my, here, right? 1.5. The area, going off this picture, the area to the left of 1.50 is 0.9332. Okay, 0.9332. So I get this purple area. So from my table A, I get 0.9332. But I need to know this dark blue area. So I just do 1 minus my table A value. And I get this value, right? 0.0668. Good job, guys. Okay, so we got 2 more. Hopefully that looks good. Go ahead and pause it or rewind if you need a little more time there. Now, the next question says, a different species of cockroach has a mean of 50, and it doesn't tell us our standard deviation. So I guess I'll just leave it standard deviation. After measuring the weights of many of these cockroaches, a lab assistant reports that 14% of the cockroaches weigh more than 55. Okay, so 14%, so that's telling you the area under the curve to the right is 0.14. And so the same would be true on the standardized curve. We just don't know this z-score, right? But this is going to help us find our standard deviation. Okay, so I did my 2 curves. I'm going to do my z formula. That's my actual value minus my mean all over the standard deviation. So my value is 55, and my mean is 50, right? And my standard deviation is, I don't know. But remember, I actually have a piece of information I didn't have before. I actually have the area under the curve. That's actually the inside part of my table. So let's look at our table A again. And well, hold on. Maybe I went a little too fast. Table A is going to tell me the area to the left, isn't it? So in order to compare the area to the left, I need to look for the number 0.86. Okay? Okay, so I'm looking for the area 0.86. So let's take a look. 0.86. Oh, those are close to 0.86. Okay, that's probably the closest number to 0.86. So that looks like a z-score of 1.08. Okay, 1.08 has an area to the left of the curve of 0.86, 1.08. Okay, so my z value is 1.08. And in my numerator, and I still have this standard deviation. So I can actually just do a little algebra here, just swap these, right? So this would be standard deviation is equal to 55 minus 50, which is 5. And I get 5 divided by 1.08. So I get my standard deviation of 0.46. Cool. So my standard deviation is 4.6. Nice. Last question. My period 7, we didn't get a chance. A tech came in. We didn't get much of a chance. So I'll try to give a little bit more info on 90. It says, this is the normal probability plot showing the scores of 551 NBA single seasons. And these are the points they made. So we learned in class a normal probability plot would look relatively straight. So if you don't have a lot of notes on this, let's just kind of take a look in our book. So, all right, here's the question in my actual book. And yeah, so see, these are looking more straight. This one's kind of curved. That one looks a little more straight, and this one's more curved. So I think we probably know our answer already. But if we flip in our book to, yeah, here's an example where if your normal probability plot is straight, if the normal probability plot is quite linear, then we can say the data is approximately normal. Here's this actually looks like our example 90. Here it says the normal probability plot is clearly curved, indicating this is not approximately normal. Okay, so these are all looking relatively straight. So here's actually the information we need. It says if points on the normal probability plot lie close to a straight line, the data will be approximately normal. Anything nonlinear in form, we would say non-normal. Okay, so I think we have our answer there. Let's take a look at our choices. We can eliminate that it's normal because it's curved, it can't be normal. Now we just have to decide. I think this is maybe a little too, but it's definitely, we've got some points trailing off at the pass. We also noticed that a lot of stuff is in, we expected it to be more like this, right? So it's like I get a z-score for this value at 200, and instead of getting this value, I'm getting 0. Instead of getting this value at -3. So it's essentially saying, instead of getting that, I'm getting a value more similar here. The value I would have gotten over there. I'm getting this value that I would have gotten over there. Does that make sense? So I'm thinking this data, and we also have some stragglers. This looks like right skewed data, where you have lots of stuff here, and then you have straggling values over here. So I'm going to circle right skewed data. Thanks, guys, for joining us. It was a pleasure.